Have you ever wondered what it would be like to travel back in time and change the past, or dart forward into the future and see what awaits us? Time travel, a concept that has colored our imaginations and permeated pop culture, from H.G. Wells' The Time Machine to the Back to the Future trilogy. It's an idea that sparks curiosity, fascination, and a tantalizing sense of the unknown. But time travel isn't just about hopping in a DeLorean and zipping off to another era. It's a complex and perplexing topic that brings with it a host of paradoxes. Consider the grandfather paradox, where a time traveler could theoretically prevent their own existence by altering the past. Or the bootstrap paradox, where an object or piece of information sent back in time becomes trapped in an infinite cause and effect loop with no discernible origin. But time travel isn't just a fanciful concept, it has roots in real scientific theories. Albert Einstein, one of the most renowned physicists of all time, gave us a theory that could possibly support the idea of time travel. This theory, known as the theory of relativity, introduces a fascinating concept called time dilation. This theory suggests that the flow of time is not a constant, but rather, it can be influenced by gravity and speed. The stronger the gravitational field, or the faster an object moves, the slower time passes for it. This is not just theoretical, it's been proven in numerous experiments. To better grasp this concept, consider the famous twin paradox thought experiment. Imagine two identical twins. One stays on Earth while the other embarks on a journey to a distant star at near light speed. Upon the space-traveling twins' return, they would find that they have aged less than their Earth-bound sibling. This happens because time for the space-traveling twin has slowed down due to their high speed, illustrating the concept of time dilation. And this isn't just confined to thought experiments. Real-life examples of time dilation exist. GPS satellites, for example, have to adjust their clocks to account for time dilation. Without these adjustments, your GPS would be off by about 6 kilometers a day. While time dilation gives us a way to potentially travel into the future, it doesn't provide a way to go back. Quantum mechanics, another branch of physics, gives us a different perspective on time travel. Unlike classical physics, which describes the universe in terms of objects moving in space, quantum mechanics deals with probabilities. It tells us that particles can exist in multiple states at once and only settle into one state when observed. This is the mind-bending reality of the quantum world. But how does this relate to time travel? Enter the many worlds interpretation. This theory, first proposed by physicist Hugh Everett in the late 1950s, suggests that all possible alternate histories and futures are real, each representing an actual world or universe. In the context of quantum mechanics, when a particle settles into one state out of many, the universe splits into different branches, each branch representing a different state of the particle. So, if we consider time as a dimension similar to length, width, and height, then each of these branches could represent a different timeline. In theory, traveling between these timelines would be akin to time travel. However, it's important to note that this interpretation, while certainly fascinating, is highly speculative and not universally accepted among physicists. As fascinating as these theories are, they remain just that, theories. So, where does this leave us on our journey through time? We've explored the enigma of time travel, delved into the theory of relativity and time dilation, and even dabbled in quantum mechanics and the many worlds theory. Yet, we are left with more questions than answers. The unresolved mysteries of time travel are as vast as the universe itself. For instance, we grapple with paradoxes that seem to defy logic. What happens if you travel back in time and change something? Does the future you return to remain the same, or does it change? And let's not forget the grand challenge of constructing a viable time machine. Is it possible to manipulate the fabric of space-time to create a portal to another time? Scientists and researchers continue to delve into these questions, testing theories and pushing the boundaries of our understanding. While we may not have all the answers yet, the quest to understand time travel continues to captivate us as we journey through the enigma of time, one tick at a time.